I'm going to continue on with the analog meter regulated power supply kit. Now, this segment's going to be a bunch of short pieces, and I don't know what exactly we'll do in them, but there'll be little pieces that lead up to assembling the power supply. So the first thing I've got is, this is a plastic front that I made for the power supply enclosure, and this is my drilling template. Once I get these holes drilled, or in the case of the big holes, I'll have to use a hole saw, I think. Then I'll replace it with this template, which I believe will be the front of the panel, with the holes all filled with switches, knobs, or meters. So first thing I'm going to do is center punch all of the applicable holes, and then I'll take it and drill it. Before I get too carried away in the front panel, here's the front installed enclosure I intend to use. And these meters will be mounted, of course they'll be mounted on the front of this, but this meter would be mounted in about this location. And you see this through hole stud assembly where it's used to fasten the top and bottom of the case together. I want to make sure that the meter doesn't hit that. And this is the ammeter. It's the bigger of the two because I put a shunt on the back of it. And it looks like all is going to be okay. So now that I've satisfied I may not make a mistake, that's never, of course, 100% sure, I can now drill the front panel and hopefully mount all the front panel components. I thought there might be some interest in seeing how this hole punch works. It consists of a cup. Right now the cup is turned up on the vise jaws, and it consists of this punch, and the punch goes down in like that. I'm going to mount the punch in the vise, and I have the template here for the front panel of this meter, and I have cross lines passing through the center of the meter. Now I've drilled out the center of the meter to accept this 3/8 bolt like that. Set the punch on top of the plastic, put the 3/8 bolt through, and tighten it in the vise. Now the hole for the bolt allows this to move a little bit. I hope it's enough. We're out in the shop area where the lighting is not really camera quality. In any event, on the side of the cup there are 4 indexing lines, and they should mount, these indexing lines vertically should line up with the center line of the hole. Just tighten it up. I should use a square drive on this. Now what I'm doing is drawing the punch into the cup, hopefully piercing through the plastic. Now they make these punches, they're commonly called green Lee punches after the most prominent manufacturer, and I'd say 99% of these are for creating round holes. They do make square ones, rectangular, octagon. These used to be affordable. A lot of things used to be affordable. They've gone up in price lately. I heard a crack. I guess when we take it out, we'll find out if what cracked. What should have happened, I don't feel any cracks. Just pop this off. There we have a nice round hole. And of course, if we take the punch apart, that is, remove the punch from the cup, there'll be what's called a coupon inside. You can't redeem it or anything. So there we see the coupon, and it has cracked. The reason for that is the punch has these two raised areas that begin to cut through the material on either 180 degrees opposite. And so this piece of throwaway plastic gets bent. You can see it cracked it. If this were metal, it would just be sort of bent but not cracked. And here's our piece of paper. So that's a better idea than sawing, or maybe even step drilling for a large hole. I think I have a set of these that goes up to 3 inch. If you have an opportunity to buy any of these, they're most often used to punch holes for electrical conduit. And so they may say 3 inch on them, which really means they punch a 3.5 inch hole for a 3 inch conduit. So it's necessary to read on the cup exactly an inch diameter. So you can't just buy a 1 inch punch. You can, but a lot of times you'll get a 1 inch conduit punch, and it'll punch a hole about 1 3/8, 1 7/16, whatever the OD of 1 inch steel conduit is. So they make these specified as conduit dimension, which has an inch equivalent, and then they make them in even inches, fractions of an inch, or metric. I'm going to fasten this front template, really the front panel plate, on with double-sided Scotch tape. Then I intend to, from the rear, cut out all the openings. My normal course of action is using a paper punch to cut out all the openings. And sometimes the alignment of the paper template with the holes doesn't quite match up. This is the completed front panel. The only thing missing is the LEDs. They push in from the front, that's no problem. 10 turn dials. Letters are a little close here. This is a power switch, on off. This is a load power switch. That powers the load, turns the load off, shorts the load out. With this in the shorted position, we can set full load current. There's going to be an LED here indicating power on. And this will be an LED that illuminates whenever the supply is in the constant current mode. This is a drawing, I'll call it. Some people might call it a template, but I'm going to refer to it as a drawing. I want to get it completely refined with all these mistakes taken away. I'll post it. What it amounts to is a drawing of the back panel. And a drawing of the heat sink. The heatsink outline contains the drilling pattern for 50 millimeter fans. Now 50 millimeter fans have mounting holes on 40 millimeter centers. So when using this template, these holes must be drilled. These are the 4 mounting holes. That leaves me with 1, 2, 3, 4, 5, 6, 7, 8 other marked holes. Only one of these other holes will be drilled per fan. And they are for the wire to pass through. Then understand the fans are going to be mounted on this surface, and the wires need to exit the back here. Now, I did not intend that you cut this template out, glue it on the back panel, tape it, and then drill the holes. That was not my intention. My intention was to cut out one of these fan drawings and then use it as a drilling guide. But I don't locate it lengthwise. If you did want to locate it crosswise, you could put a piece of masking tape down here and draw a center line, and then use this pre-printed center line to line up with the... Okay, that would get you this way. That's not the way I really intended it to be used. What I intended to do was line it up with the edges of the heat sink and then bend it over and crease it on both sides. that means we have a guide, which can be slid along the heatsink, the edges being folded over, located crosswise. You might ask why I did this. Well, I don't know what heatsink you may use, but you'll notice I've extended the center line of these holes over the edge. See how they extend beyond? Well, they end up being bent here. See, here they are extending down. Now, it would be important that these mounting hole not hit a fin. So by sliding the guide, so this, for example, is a mounting hole center line, as is this, and these two are through holes for wire. So we slide the guide back and forth until this one, this one, this one, and this one miss the fins. Okay, so now you see I'm going to drill a hole here and here. They're mounting holes for the fan. Then I may drill a hole here or here for the wire. In any event, since none of these holes, when drilled through, will hit a fin, so I think I'm going to mount this. Now what I'll do is just take a piece of masking tape, fold one corner over, and there we have our guide slash template. Why did we fold the end down? Well, so we can pluck it off. Now what I've done is I folded the wires back and pushed them through the strain relief. That was an attempt at trying to maintain a little bit of strain relief here. Well, the heatsink fans are mounted. In fact, we will turn them on. Nice air exiting out the sides. I used bushing material here where the fan wires pass through. I've hooked the fans in series since they're 12-volt fans. The shroud was merely wrapped around like you would wrap a wire around a screw, and tightening the screws up may have caused them to expand, so I put a washer on there. And then I put self-locking nuts on the back. Still have the standoffs to mount. And for you that were watching closely, you'll notice that I had to re-drill the hole. So this will be mounted on the rear of the enclosure. So there is some noise there. Perhaps I could have used rubber to mount the fan somehow. Maybe a strip of rubber down here and rubber washers up here. But we'll see how annoying it is when we're done. What I haven't done, and you'll see there's not any evidence of them, I have not yet drilled and tapped the holes for the standoffs. I've drilled 5 holes, no good reason, for standoffs. And I'm going to, just by eye, line this up with the plastic back plate. I've got another transfer punch here. Put it in this hole, and I've merely put just one little dent in the plastic. Here's the completed back panel. Well, it's not complete. I have to drill or cut out the IEC connector opening. Here's the fans and how they are mounted. Brought the wires from the heatsink mounted devices through the back of the panel. So here's the completed front and back panel assembly. So the front, and here's the back. Now I have to decide what to do with this handle. I'm going to end this now. The next segment will be mounting the IEC connector and the internals inside the enclosure. We'll do a quick power up, and then I'll probably do yet another video with some testing. If you like this kind of stuff, come back, give me a thumbs up, make a comment, or subscribe. Thank you.